Let's start. Is my screen is shared to? No, it's not shared. Yes, now is it shared?
Yes.
Okay. We were doing October November 21 paper 2-1 and we have ended over here and now we are continuing onwards. Part the compound As2S3, we can call it arsenic sulfide, is a common mineral. When arsenic sulfide is heated strongly in air, it forms a mixture of products as shown. So here I have a chemical equation. A sample containing 0.198 gram arsenic sulfide is placed in 0.1 mole per dm cube pure oxygen. And so oxygen is in excess, which means that it must be a limiting reactant. In a reaction chamber connected to a gas syringe at room temperature, okay, the reactant are heated until no further change is observed. The product are then allowed to cool to room temperature. Okay, so calculate the volume in dm cube of a gas present at the end of the experiment. Okay, the molar volume of gas is 24 dm cube. Under these conditions, assume that the pressure is constant throughout the experiment. So if you see what they have provided me the mass of arsenic sulfide and I have to find the volume of gas. So in equation I can see there are 2 moles of arsenic oxide and 6 moles of sulfur dioxide gas. So we know that 1 mole occupies 24 dm cube. So if there are 6 moles, so I can conclude from the equation that 6 times 24 decimeter cube of food is being produced. Now, if we look at arsenic sulfide, so we have to look at the periodic table for its mass. If you look, and if you find arsenic, here I have arsenic. It's 74.9, right? It's 74.9 and sulfur is 32.1. So it would be 2 times 74.9 plus 3 times 32.1, and this whole thing gives me its MR. And if you see in the equation, there are 2 moles are being used, so I make it times 2. Now, in the experiment, we have used 0.198 gram of arsenic sulfide. So what would be the volume of gas produced? That must be X. So I made the ratio, I have to find the value of X. So X would be 0.198 multiplied by 6 times 24 divided by 2 times into 2 times 74.9 plus 3 times 32.1. Can anybody solve it in the calculator and then send it to me? What is the value of X? I'm going to get the volume directly. Yes, can anybody solve and tell me the correct answer? So
0.072.
0.072. Are you sure it's 0.072?
Yes.
0.072. So it would be 0.072 dm3. Yes, is this question is understandable to everyone? If anyone have any doubt or query, do ask. Okay. Yes, is this question is clear to everyone?
Yes, sir.
Now, state the environmental consequences of releasing SO2 into the atmosphere. So we all are very much aware that the SO2 causes acid rain if it is present in the environment or atmosphere. So I can write only that it's an acid rain. Okay. Now, the next part, sulfur dioxide gas can be removed by reacting it with NaOH. Construct an equation for the sulfur dioxide gas with NaOH, including symbols. Okay, so it is a sulfur dioxide gas reacting with sodium hydroxide. So what would be the product? If we talk about sulfur dioxide, so it's an acidic oxide. So on dissolving in water, what it would form? H2SO3 sulfurous acid, and when sulfurous acid reacts with NaOH, we get sodium sulfite Na2SO3 and water. So it means that if I react directly with sulfur dioxide with NaOH, the same reaction will take place. So here it is Na2SO3 and there is a group 1 element in it. So you must remember that all the group 1 compounds are water soluble, so it must be aqueous. Then we are getting water over here. So to balance the equation, I just need to put 2 over here. Yes, is this clear?
Yes, sir.
Now, next part. Actually, it is question number 2. Okay, it's question number 2. See, only question number 1 have 21 marks out of 60. So let's do the work over here. That in the reaction when nitric acid is used and we got calcium nitrate. When it reacted with calcium, sodium hydroxide, we will get calcium hydroxide. When I heat it, calcium nitrate decomposes to give you calcium oxide. Okay, so here we need to heat and then we have to react with carbon. Okay, then in reaction 2, calcium hydroxide reacts with carbon dioxide, forming calcium carbonate and the excess of carbon dioxide. Okay, so what they are asking, reaction 1 produces calcium nitrate and one other product, identify the other product. So if you look at reaction 1, the other product must be hydrogen gas because an element is being reacted. So we will write hydrogen gas. Is this clear?
Yes, sir.
State construct an equation for the thermal decomposition of calcium nitrate. So when we decompose any group 2 nitrate, So it on heating it decomposes to give you calcium oxide, then nitrogen dioxide, and then oxygen. So to balance the equation, I have to put 2 over here and half over here. Is this clear? Now in the next part, they are asking state the trend in thermal stability of group 2 nitrates down the group. So as we move down the group, the thermal stability increases because as we move down the group, there are strong forces of attraction between the ions. And there is very less distortion of the anion. So it's for 1 mark. So I have to state the trend. So I can write that thermal stability so the trend is that stability increases. Now the fourth part. In reaction 3, dioxide is bubbled through water containing calcium carbonate. A solution of calcium hydrogen carbonate forms. Write an reaction for equation 3. So we have the equation for reaction 3. So if you look at the reaction 3, calcium carbonate is reacting with water. Okay. And we need the carbon dioxide as well. So construct the equation of calcium carbonate reacting with water and carbon dioxide. 1 minute, sorry. So it is reacting with carbon dioxide. So the compound form is calcium hydrogen carbonate as they have given us. So we will put the 2 in the subscript for the formula. Describe how calcium hydroxide is used in agriculture.
सर एसिडिक सॉइल को न्यूट्रलाइज करने के लिए
Okay. It is used to neutralize acidic soil. Okay. Okay, now C part. In reaction 4, calcium carbide CaC2 is formed from CaO. CaC2 containing C2 negative anion. Each carbon in C2 negative ion is sp hybridized. Describe how sp hybridized orbital are formed. So when we talk about sp hybridization, there is the name is telling me that there is one s and one p. So I may write that it is the mixing of one s and one p orbitals. So when one p and one p and one s mixes or hybridize, then that is called sp hybridization. In the next part, they are asking sketch a diagram to show how two sp hybrid orbitals can form a sigma bond. So to form a sigma bond, that whether it's an sp orbital or sp2 or sp3 orbital, so these are the hybrid orbitals that are formed, and these two are being hybridized and then overlapped. So you need to draw this diagram over here only. These two initially without overlapping, and then when they get overlapped. Is this clear? Now D part.
सर ये इस टाइप के क्वेश्चंस कौन से चैप्टर के पार्ट
कौन सा वाला क्वेश्चन, ये वाला?
मतलब ये हाइब्रिडाइजेशन से पहले वाले पार्ट ही से पहले वाला और ये जो नीचे आ रहा है
देखिए ये तो ग्रुप इनऑर्गेनिक के हैं, group 2 period 3 and group 17, so that you wouldn't have done yet, so we will do it this. Okay, the flow chart shows some reaction of CaC2. Okay, on first reaction with nitrogen, CN2 is formed, and then with water it is hydrolyzed to give you calcium carbonate and ammonia. And if it is reacted with sodium chloride and carbon, we got NaCN. Reaction 5 can be used to prepare ammonia. Okay, here I have an equation. Calculate the minimum mass in tons of calcium cyanamide, CaCN2. 1 minute, please. Okay. So calculate the minimum mass in tons of calcium cyanamide, which is this one. That is required to produce 1.5 exponent 6 tons of ammonia. Okay. So first we take the ratio from the equation. And 1 minute, calculate the minimum mass in tons of calcium cyanamide. Okay, so if you look at the equation, I can take the ratio of mass of calcium cyanamide is to mass of ammonia. So mass of CaCN2. Can anybody tell me the MR of CaCN2? There are 2 nitrogen, which makes it 19, 19, and 1 oxygen. Mm-hmm. 1 minute. Yes. Nitrogen have a AR of 14. There are 2 nitrogen, which makes it 28. Carbon is 12 and calcium is 40.1. So if we add it, we will get Okay. So if I add, yes, can anybody tell me the answer, the MR of CaCN2? Yes, calcium is 40.1. Carbon is 12 and 2 nitrogen 28. So 28 plus 12 gives you 40 and 40.1. So I can say 80.1 grams of calcium cyanamide is used to form ammonia. And if you see, nitrogen is 14 and hydrogen is 3. So which makes it 17, and 17 times 2 makes it 34. So 80.1 gram of CaCN2 forming 34 gram of ammonia. Is this clear? So if we look in the question, there is 1.50 exponent. No, it is the mass of ammonia, sorry. So how much mass of CaCN2 is needed? That is X. And the mass of ammonia is 1.50 exponent 6 tons. So if I'll calculate the X is equals to 80.1 into 1.5 exponent 6 divided by 34. So can anybody solve and tell me the answer? Yes, please. जी आंसर क्या आ रहा है?
Sir, 3.53 exponent 6.
3.53 exponent 6, and that answer I got over here is in 10 only. And see how it could be in 10, because if you see that this 80.1 have a unit of grams, 34 is also have a unit of gram, and this have a unit of tons. So these two units are cancelled out and we are left with the tons. Is this clear?
Yes, sir.
Okay, now what they are saying, draw the structures of the organic products formed in the following reaction. Okay, so when we use cyanide, what would happen that the halogen is actually removed by the cyanide, forming a nitrile. So this one is nucleophilic substitution reaction. If you see, we are heating it with by mixing sulfuric acid, which means it is hydrolysis. And see, one more thing that they have mentioned you, that organic products. So when I hydrolyze this, the organic product formed it have a OH group. No, sorry. CH2, and then the third carbon is nitrile, which is converted into carboxylic acid. Okay, so now if you look at the second reaction, we have a ketone, and that is reacting with NaCN. So in case of a ketone, what would happen? That this double bond is broken down. We have a OH group bonded over here, and we have a CN group over here. Yes, is this clear?
सर ऑर्गेनिक में बस इतना ही डिफिकल्टी लेवल होता है.
जी हाँ, इससे ज्यादा नहीं होता.
सही.
Nucleophilic substitution, and this reaction is nucleophilic substitution. Okay. Now, okay, here question number 2 is ended. Now we are heading for question number 3.
सर एक मिनट ऑर्गेनिक वाले पार्ट को ऊपर करिएगा.
जी.
सही.
Okay. Now question number 3. Phosphorus is a reactive period 3 element. Phosphorus have a several allotropes. Detail of the two allotropes are given. One is P4 with a melting point of 44, and the other one is red color phosphorus have a melting point of 590. White phosphorus and red phosphorus both have a covalent bonding. Okay. That is the type of structure shown by white phosphorus P4 and red phosphorus P. Okay. So we have to tell the type of structure. Explain why red phosphorus has a higher melting point than white phosphorus P4. So yes, can anyone comment on the structure?
सर जायंट और सिंपल होगा.
Yeah, very good. Because phosphorus is non-metal, so they only make covalent bond. So for P4, as its melting point is just 44, so we can write that it is simple molecular, and for the structure of P having a melting point of 590, we can write it's a giant molecular. Now, the difference in the boiling point is because in P4, there are weak intermolecular forces which are broken down and in phosphorus there are strong covalent bonds which are broken. Yes, is this clear?
सर ये जाइंट मोलिकुलर में कोवेलेंट बॉन्ड्स होते हैं.
जी हाँ, giant, yes, giant molecular. For example, you look at diamond, graphite, or silicon sand. They always have a covalent bonds. Yes, is this clear to everyone?
जी.
Okay. Now, red phosphorus P forms when white phosphorus P4 is exposed to sunlight. Okay, so due to sunlight, P4 is turning into phosphorus, white phosphorus into red phosphorus. Use this information to draw a reaction pathway diagram to show the formation of red phosphorus from white phosphorus. See over here that the delta H is negative, which means it's an exothermic, right? So if it's an exothermic, the energy is being released, which means the the red phosphorus which is formed have lower energy, and then we will make this the arc like this. Is this clear? Anybody have any doubt? Kindly ask.
सर एनर्जी डायग्राम में बस इतनी ही सिंपल आता है बस.
Yes, it depends. See the number, the marks. See, and further, they didn't mention it's an energy diagram. They just say the reaction pathway and it's of 1 mark. If they instead they have written energy diagram and it's for 3 marks, so we have to label activation energy over here, and then delta H over here like this. But here for 1 mark we don't need to. Okay.
सही.
Okay. Now next part. Some reactions of P4 are shown in the reaction scheme. Okay. With the excess chlorine, phosphorus is converting into PCl5. With the excess oxygen, it is converting into P4O10. In reaction 1, PCl5 when added with water. So if you recall, it turns into phosphoric acid and 5 moles of HCl. So when I dissolve P4O10 in water, the same, it converts into H3PO4 only, that is Q. This is due to this PCl5, and here when we add P4O10, HCl would not be formed. Okay. State the oxidation number of phosphorus in P4O10. So let's do a little work to identify. P4O10 have a no charge on it, so it means net charge must be 0. We know oxygen is most electronegative in this case, so it have a -2 oxidation number, and there are 10 oxygen, which makes it -20. So it must mean that the phosphorus have a +20 to get the charge 0, but there are 4 phosphorus atoms, right? So it means each phosphorus have a +5 oxidation number. So I will write +5 over here. Is this clear?
Yes.
Okay. Now
सर ये समझ नहीं
use
आया
and
मुझे.
this. Okay. Wait. See, Abdur Rafe, it's P4O10, right? In P4O10, is there any charge on it? Yes.
No sir.
So it means whatever the charges these oxygen and phosphorus have, the sum of these charges must be equal to 0, right? Is this clear?
Yes.
Okay, so when you review redox, in redox we have discussed the order of, choosing which element oxidation number would be placed first. So that order says first you will put the oxidation number of group 1, 2, and 3, but there is no element from group 1, 2, and 3. Then put the oxidation number of hydrogen. There is no hydrogen over here. Then put the oxidation number of most electronegative element. So in this case, the oxygen is most electronegative. So its oxidation number is -2. So there are 10 atoms of oxygen. So it becomes -20. And we know that the net charge is 0. So if net charge is 0 and oxygen have a -20, which means that the phosphorus must have a +20 oxidation number. Now is it clear, Abdur Rafe?
Yes, sir.
And there are 4 oxygen atoms and the charge is +20. So it means each oxygen atom have a +5 oxidation number. Is this clear now?
Yes, sir.
So that's why I've put +5 over here. Now reduce the identity of Q and hence construct chemical equation for reaction 1 and 2. So if we talk about reaction 1, as I have shown the product, we would get H3PO4 and 5HCl. In reaction 2, I'm just going to get H3PO4. Now let's balance these two equations. So here, how many total hydrogen atoms on the product sides are 8. And here I have a 2 hydrogen atoms, so I put a 4 over here. So see, hydrogen gets 8 and balanced on both sides. Oxygen becomes 4 and gets balanced on both sides. There are 5 chlorine on the both sides, and there is 1 phosphorus on the both sides. Now in the next equation, I must have to put 4 over here because there are 4 phosphorus, right? So if I put the 4 over here, which makes it 12 hydrogen over here, so I must put 6 over here. Now my equation is balanced. Is this clear? Yes, if anybody have any confusion, kindly ask. Yes, is this clear to everyone?
सर थोड़ा जूम आउट करके ऊपर वाला भी दिखाएगा.
Yes.
सही है. सर देख लिया.
Okay, am I audible to everyone?
जी.
Okay, and my screen is shared now. Okay. Yes, is it clear till here to everybody? Now, triphenylphosphine is used in a type of reaction known as Wittig reaction. So here you have a structure of triphenylphosphine, and they have shown you that this structure is basically C6H5 and this is the empty bond. Give the empirical formula of the triphenylphosphine. So there are three C6H5. So if there are three C6H5, which means if there are three C6, so 3 times 6 give you C18 and 3 times 5 give you 15. So C18, H15 and 1P in the center. If I try to simplify it, I can't. So it is the most simplest form. So it must be its empirical formula. Is this clear now?
जी.
Okay. Now next part. In a Wittig reaction, an aldehyde reacts with a halogenoalkane. When we talk about aldehyde is a carbon having a double bond O and bonded to hydrogen. A halogenoalkane is any structure in which a carbon is bonded to an halogen to form an alkene. Okay, so these two are reacting and we are getting an alkene structure in which a carbon-carbon double bond is there. This conversion is shown in the following unbalanced equation. Okay, here I have a unbalanced equation. So if you look at this equation, what is happening over here? That I is being removed over here, O is being removed over here, and one H is also being removed over here. That's why we are getting a carbon-carbon double bond. Okay. Further, what they are telling us about compound H, that compound H can be made from propanol. Okay. Stage 3 in the reaction scheme is a Wittig reaction. Okay. So in stage 1, the propanol and aldehyde is treated with NaBH4 and it's a reducing agent, which means reduction occur, and due to this reduction the G that is formed over here is C2H5, and then instead of CH2 it's CHO, it's CH2OH, because on reducing aldehyde we get a carboxylic acid. If you look at stage 2, this G, that is, if I would write, it would be C3H7OH, is reacted with red phosphorus and iodine. So OH is displaced by I. So it is a nucleophilic substitution. Then if you see, so this is basically the reference given to you to form H. So see over here, I have a C2H5 bonded to C, and that C is bonded to I, and this C have two hydrogens reacting with C2H5 C double bond OH. So from the above information, what we can conclude that O is being removed from here, I is being removed from here, and from the same carbon IH is being removed from here. So if all of these are removed, so see what would be left? We are left with C2H5 and a C that is bonded to one H, because one of the H and one of the I is removed. Okay. Then in aldehyde, we are left with C2H5 bonded to a C, and that C is also bonded to an H. And from the above reference equation, I can conclude there must be a carbon-carbon double bond over here. Is this understandable? So that is the H. Yes, is this clear? If anybody have any doubt, kindly ask, please. State the type of reaction that occur in stage 1. So stage 1, as we have already concluded, that it is reduction. Now in stage 2, what we have decided that it is nucleophilic substitution. Is this clear? Now draw the structure of G and H in the boxes. So we have drawn G, we have drawn H. So for G, I will repeat the above structure, which is C2H5 CH2OH, and for H, it is C2H5 CH double bond CH C2H5. Is this clear? Yes, is it clear?
Clear, sir.
Okay, now next part. Identify the organic products formed when compound J, shown below, is heated with hot concentrated acidified magnate. So see, it have an alkene, and whenever we use hot concentrated acidified magnate, that the molecule is broken down from a carbon-carbon double bond and split into two parts. So I got the one part, this one, and the other part, this one. So these are the two carbons from where the bond is broken down. If you look at the structure on the right, the carbon which have initially double bond and now it is broken down, it have a two carbon chains on its both the sides. So it means it is will be converted into ketone. And to make the ketone, what would I do? I would put a double bond on that carbon from where the double bond is broken down, and then write an O. So if you look
सर कीटोन का कैसे पता?
at this carbon over here, it is the carbon. So oxidation, and specifically the oxidation of, alkenes. Let me show you. Where is oxidation? Here it is. See, if this double bond is 1 minute, if this double bond is broken down, if you look at this yellow carbon, it have a two carbon chains. So see, that carbon is converted into a ketone, right?
सही है.
So we applied this thing over here. So see over here, this is the carbon which have a double bond, and on both the sides it have a carbon chains. So this carbon, after broken down, must convert into a ketone, and for that I did this thing. Is it clear now?
जी.
Okay, now if you look at this carbon have a one hydrogen over here, and here we have a CH2, which means this carbon have a carbon chain on one side and the other side hydrogen. So the carbon which have a double bond and have a one carbon chain and a one hydrogen is always converted into carboxylic acid. So what I would do, I would make a one double bond O and then OH. So that's how we will make the structure. Is this clear? Yes. If anyone have any confusion, kindly ask. Okay. Now, this is question number 4. Oh, let's see. Okay, let's give it a try. Compound B is a liquid with a fruity smell. So if you see, it have a this functional group in it, which is an ester, and ester have a fruity smells. Okay. And here we can conclude that it also contain an alkyl halide or a halogenoalkane. Is this clear? Now, the reaction scheme shows how B can be made from ethanol. Okay. So what we did, we do the oxidation of ethanol. So it's a primary alcohol and here I'm getting ethanoic acid. So it is oxidized. That's fine. In reaction 2, if you see here, there must be a CH3 and that CH3 becomes now CH2 and one of the hydrogen is substituted by bromine. So I can call this reaction free radical substitution reaction which occur in UV rays or sunlight. Now if you look at reaction 3 is esterification because if you see over here that the OH is bonded removed from here and the H is removed from here to form water and this oxygen must be bonded over here and see that's what actually occurred. Okay, reaction 1 is an oxidation reaction, they have told you, but we already figured it out. Give the reagents and conditions required for reaction 1. So for reaction 1, the reagent would be potassium, so potassium dichromate is the reagent and it's potassium dichromate 6. So what are the conditions? One condition is the acidic condition, we need an acidic medium, and the other condition is heating under reflux. So I would write in conditions acidified and heat under reflux. Is this clear? Now, what they are saying, construct an equation to represent reaction 1. Use atomic O to represent the oxygen atoms from the oxidizing agent in this reaction. Okay. So let's look at the reaction number 1, where ethanol is converting into ethanoic acid. That is reaction 1, right? So ethanol is C2H5OH. We showed that we got atomic oxygen. So here I would get CH3, COOH, a carboxylic acid. Okay. Okay. So this is the type of reaction that occur in reaction 2. So we already discussed that it's a free radical substitution. So I would write it's a free radical substitution. Okay. Next part, sulfuric acid, H2SO4. Okay. Where would we? Sorry. Sulfuric acid acts as an homogeneous catalyst in reaction 3. Explain why sulfuric acid is described as a homogeneous. So if you recall, homogeneous catalysts are the one which have a same state as the reactants. So we just write homogeneous catalyst homogeneous catalyst means that homogeneous catalysis mean that the catalyst is in same phase as the reactant. Is this understandable?
सर एक मिनट ऊपर करिएगा, ए वाला छोटा करके दिखाइएगा पूरा.
जी. Are you done, Abdullah?
जी.
Reaction 2 needs to take place in the absence of water to prevent formation of compound C. If C is present in the reaction mixture of reaction 3, a different compound D will also form. Compound D has a two identical functional groups. The infrared spectrum of D shows a strong absorption at 1100 centimeter inverse and 1720 centimeter inverse, but no absorption due to OH bond. Use the data booklet to identify the functional group present in D. Okay. So if you look at the data booklet, the infrared table, you will find that this signal is due to carbon-oxygen single bond, and this signal is due to carbon-carbon double bond. And no absorption at OH, which means there is no OH group. So we can state that the absorption at 1100 centimeter inverse carbon oxygen single bond and the absorption at is due to carbon-carbon double bond. So here you have secured 2 marks. For the third mark, you have wrote these 2 statements. Number 3, we can say that D is an ester. Okay, 1 minute. D is an ester because it have a C double bond O and C single bond O as well. So it might be an ester. And there is no COOH is an molecule. Yes, is this clear? If anybody have any doubt, kindly ask.
Clear.
Okay. Okay, I think we can finish this paper today. See, we are adding sodium carbonate, right? Here, it's an acid. Who left the class? Okay. And this is an alcohol. So sodium carbonate would react with only the alcohol, sorry, only the acid. So the H is being removed from over here.
सर ये कैसे पता चलता है सिर्फ अल्कोहल के साथ रिएक्ट करेगा?
ये आपको याद करना पड़ेगा। सोडियम कार्बोनेट सिर्फ कार्बोक्सिलिक एसिड के साथ रिएक्ट करेगा। देखें अल्कोहल के साथ तो रिएक्शन ही नहीं हुआ। Okay. Now they are asking you to draw the structure. So we already drawed it. So we draw it over here, and a positive O negative bonded to C double bond O, and that is bonded to CH2OH. Okay. Now suggest why NaBH4 is not a suitable reagent to make F. From C, explain your answer. Yes, who can explain this answer? It clearly indicates that it is not a strong oxidizing agent. Although it's an oxidizing agent, okay. Now next part, construct an equation for the reaction of CH2OH twice with SOCl2 to form G. Okay, that is the reaction that we have studied in, nucleophilic
Alcohol.
substitution of alcohol. So CH2OH twice is actually this. There is a OH bonded to CH2, and that is bonded to another CH2 and have an OH. So if I treat with SOCl2, I need two SOCl2, and what would happen? That both the Cl group are substituted with SOCl2. We got two chlorine over here, and we would get two, not sorry. Sulfur dioxide and water is also formed. Now, the last part. Explain why C is very soluble in water. If you look at C, where is C? And if it's soluble in water, it clearly means there is a one property which a covalent complex in water is a hydrogen bond between its molecule. So I can write that C can form hydrogen bonds Okay, we have to mention that it is getting dissolved in water, so it can form hydrogen bonds with water. And that's it. Here we have ended the paper. I will share a new paper tomorrow and we will continue that paper in the class, okay?
सर ये हर वाटर सॉल्युबल चीज के लिए लिखा जाएगा?
What?
मतलब अगर किसी भी चीज के बारे में पूछ लिया जाए कि वाटर सॉल्युबल क्यों है तो ये हर बात में हम लिख सकते हैं ये बात?
If
वो
it's a
हाइड्रोजन
if it's a covalent substance and further it have a hydrogen that is bonded to a fluorine, oxygen and nitrogen, then it can form a hydrogen bond. Okay?
जी सही है.
Okay. So see you everyone in the next class. Okay, take care everyone. Allah Hafiz.
Allah Hafiz.